here, and as soon as Mr. Park gets those copies to us, I'll have a handout for you guys to follow. But first, on this recap, you guys gotta be careful. I'm thinking about the exam, next exam. Exam 4, someone might want to check me. I know this Wednesday we have a quiz. Quiz 6, I guess. And then I think next Wednesday is another quiz. Quiz 7, probably. The following Wednesday is your next exam. Exam 4. Okay, and that's going to cover all of chapter 4 and part of chapter 5. So we've got to be very, very careful with this chapter 4 coming up. Here's what I got to do with us tonight. To do a little recap here, and not go crazy here on this. Some things to point out, and you guys can help me here. In a little recap on all this. Let me just start out with, yes, when I say inverse function, definitely, I know the notation, you know the notation, so I should find that. Anyone tell me what would be appropriate, now I'll use a different color, to place here in order for us to find an inverse? That original function has to be a what type of function? What should go along with this? What types of functions have an inverse to begin with? Some functions do not have inverses.
Odd.
Ah, not odd.
Linear?
No, tell me again?
Linear?
No.
1, 2, 1.
1 to 1. There must be 1 to 1 functions. If it's not a 1 to 1 function, you must place, when you finally see one of these on a quiz or an exam, it has no inverse. It's going to be 1 to 1. Now, since we have not seen each other, I thought, I'll start with this. Given f of x is equal to this. Why not? We'll just jump right into it here. X subtract 3 squared. Find this function's inverse. That's the way I'm going to open up the discussion. Guys, look at it. Anyone have any thoughts about the shank? It has no inverse. So how is Shane looking at this? And tell me quickly, Professor, I'll put down the quiz, no inverse, and move to the next problem on the test, quiz. Shane, tell the class what, just by observation, what tells you, don't worry about it. This one has none. Has no inverse.
The graph is a parabola.
Hang on. I love that. This is all connected. She says, wait, Professor, on the side here, I'm going to do this now. He says, if I should sketch that function for you, it's a parabola, shifted what? 3 to the right. Is there a horizontal shift?
Yes.
3 to the right. We've got those in here. So she's telling me, Professor, go 3 to the right. And she's telling me, I think she's telling me, might I have a parabola doing something like this? Yes or no? Is that the graph of x minus 3 squared? Please tell me it is. Is it?
Yep.
Or is the parabola shifted 3 to the right? Okay. Now she tells me, Professor, it's not 1 to 1 though. Now since I have the graph in front of me, Shane, you can add to this. I'm going to use something called the horizontal line test. Recap here. Guys, if I draw a horizontal line where I wish, would that horizontal line intersect my red graph in more than one point? If it does, it's said to be not 1 to 1. So this function is not 1 to 1, therefore it has no inverse. That's all you're telling me at this point. Now though, I'm going to comma. Now I'm going to add to it, that one has no inverse, I've added to it this. A condition. Now with that condition added to the given, You think it's possible now to find an inverse? Yeah, if I go back to my red graph, it says now consider only the part where what, x is greater than or equal to 3. And Shane, with what you gave me, I'm going to now erase this and have only that. It's at the graph now. Now, would this pass the horizontal line test? Therefore, this one has an inverse. So we're going to find the inverse now. To find the inverse, only 2 steps. Step 1, since it is now 1-to-1, step 1 is to interchange the coordinates. In other words, make this the x and this the y. Step 1. Step 2, and the last step is solve for y. Guys, I've got to get the y by itself. Now look at step 1 and tell me something I could do algebraically to try to get that y by itself. Again, I could take the square root. Now if I take the square root, please tell me would I end up with this? If I want the y completely solved for, move the 3 over, am I looking at this? As soon as I get the y correct, if it's correct, and the y is completely by itself, I've solved for y. Guys, this is what they identify as the inverse. So that's the inverse of this. And there's the graph of the original function. Wow. Now, just out of curiosity, before I go any further, can someone in this class tell me, in the original function, since I have a red graph there, can anyone tell me an ordered pair that is guaranteed to belong to this function? The way this function is defined, tell me one ordered pair, x and y, that for sure would be belonging to the function. Anyone?
4 and 1.
4 and 1. Hang on now. I'll replace x by 4. 4 subtract 3 is 1. 1 squared is 1. Correct. Now, if this is correct, if this is the inverse, I should be able to interchange this down here and make it that. This, if it works. This says now replace x by 1. If I replace x by 1, square root 1 is what? 1? 3 plus 1 gives me a what?
4.
4. So with that one ordered pair, it did interchange. My concern is, there's lots of ordered pairs out there. Is there one a student could give me besides 4 or 1 that maybe when I flip it, check it, it will not check? That's my concern. Someone give me another one before I show you something here to do for a check. Give me another ordered pair guaranteed to be or belong to that original function besides 4 or 1.
7, 16.
Do it again.
7, 16.
7, here we go. And Julie, I think I heard you say 16. Yeah, 7 subtract 3 is 4. 4 squared is 16 is correct. Now, if this is the inverse of that function, I'll turn that around that she gave me and hope for the best. So the 16 here, square root of 16 is what, 4? 3 plus 4 gives me a 7. Looks like it's working. How many ordered pairs are there out there? Infinite. So I may stand here and check 10, 15, 20 that students give me, 30 ordered pairs, and all of a sudden, way out there, there's one hanging out there where, it didn't work. Thank goodness for us in Math 2 pre-calculus, most of these will work. Now, since we don't have the time to check all of them, here's the way we're going to check that inverse. We're going to take a composite, hit like this, of x, and we should get x. And I'll explain to you why we should get x here. But that's like a definition. So if you take a composite, you guys had a composite on the exam, take a composite, the function with its inverse, I hope you get x. If I don't get x, we've done something wrong. Here we go. We know what this means. This means, let me do it like this. F of, and the inverse, different color here, is this. This. Is that what that means? Which means go to the red function and put the black. go to the red function, well, go to the, I didn't put it in red here, go to the F function up here, and replace it. And guys, please tell me if I do, let me do it in red. It says take that up here, replace it, and please tell me, do I end up with, help me out here, what would I end up with? And we think the inverse is what again? Better put it down here. We think it's 3 plus radical x. Yes or no?
Yes.
Now if I take that 3 plus radical x back here, replace it, it's gonna look like this, and do not let me make a mistake here, stand close to the board. Square root x minus 3, I think that's being squared. Is that the way it looks if I take this back to the original function? Clean it up, 3's cancel. I'm squaring the square root of x, which is x. You're supposed to show a check in both directions. I've seen some of these functions where they will check in one direction and not the other direction. When I say the other direction, this should also work. If I do the inverse first for a composite on F, turn this around, which means F of the inverse, that should also give me X in the other direction. If not, I cannot accept this inverse over here. Guys, I'm gonna try this. It says F of, did I turn that around correctly? Inverse of F. And this says inverse, here we go. Now the original function, F of X in this case, was this. In black, so I can see it myself. X subtract 3 squared. Gotta make sure I put all this in correctly. Is that good right there at that point? I think. Is that true, guys? We're going backwards. We're going F inverse with F for a composite. Was this F of X, by the way? Was that? And then we're supposed to take that what? Into the inverse answer. We think the inverse is this. Where was it? Down here. 3 plus, here we go, square root, and in place of X, I'm supposed to put this. I know I've got all these different colors going on. Is that the translation? Clean that up. We got 3 plus, and guys, that square root of X minus 3 squared, is that merely X minus 3? 3's cancel, what do you end up with? X. Did I get an X on the composite in both directions? If you don't, you cannot accept that inverse. That's a little check there. By the way, since I have the graph there in front of me, Shane, you help me out with that. This is, hang on, this is the graph of F. Let's put it like this. Now, I need someone to tell me, I'm doing black here, how to, I like to graph this. This is supposed to be that red one's inverse. I like to graph this on the same grid. Does anyone know how to graph quickly? 3 plus square root X.
Would that shift the 3 units to the top?
Vertically shift what? The square root, parent square root function, what, 3 vertically up?
Yeah.
Okay, here we go. Let's go up 3. Now the square root function, remind me, did it look something like that?
Yeah.
But now it's up here, doing this.
Yeah.
Yes or no?
Yes.
Are they going to intersect? This is 3 plus square root X. You guys think they're going to intersect or not? Just out of curiosity.
Yes.
Does anyone know the intersection point?
No.
What does that black, what's that black curve and that red curve have in common? Does anyone see it, or should I set up an equation and find it? Does anyone think they know the ordered pair there shared by both these right here, this intersection point? Anyone have an idea? Is it 1, 1? Is the point 1, comma 1? Does that satisfy both those? If I replace x by 1, I get here 4. If I replace x by 1 down here, do I get 4? Please tell me. That's actually out of curiosity, I just threw 1 in there. Shane?
I've got a question. Don't we have to abide by the domain of f of x?
Beautiful, beautiful. Hang on, we're not quite finished yet. Okay, are we okay, guys, so far? Now, Shane. By the way, guys, do you think at this point, this point right here might be 1, 1? Is it on the red graph and the black graph? And you say, Professor, why 1, 1? I just chose that just to point it out. Shane says, Professor, the restriction was here, what, x had to be what? Greater than or equal to 3. Maybe it's 3. Maybe it's 3 something. Let me replace by 3 here. If I replace 3 by here, I get 0, don't I? If I put a 3 down here, I get what? 3 plus square root 3, right? Are they the same? No. Now I get 0 here, and that's strange 3 plus square root 3, so that's not the intersection point. Just out of curiosity, does anyone think they know the precise intersection point of that? And it might be some strange point. Or if you can't see what it is, do you know a way to find it? I'm just out of curiosity. I wasn't going to do this at first, but I thought, no, come on. Let's try to find that intersection point. Guys, if I was going to find what they have in common, could I set this function equal to this function? And see, where are they equal? These other two functions, aren't they over there? So set x minus 3 squared equal to 3 plus square root x. I may have got myself in trouble here. And solve for x. Is that true? Is that the way to do it? Guys, I'm going to expand this out. It may be wise. I don't know. X squared subtract 6x plus 9. 3 plus square root x. I did not square both sides, just squared the left-hand side. Now it looks like that. I cleaned that up somewhat, move that 3 over. Make this x squared subtract 6x plus what, 6? Yes or no? Yes. Oh my goodness, I got myself in trouble here. Then what might you want to do? You may want to square both sides. Look at this. Now, am I going to take the time to square this mess? No. But is that the approach to take? And then square the other side and I get that. Whatever that would be, if you were patient enough to go through all the algebra there, that should give you this intersection point. Now, Mr. Park, I'm just threw this together. Could you maybe this function 3 plus radical x and this function, could you see what they have in common? We're looking for that common intersection point.
Oh, okay.
In other words, set this equal to this.
Okay.
We did, but the algebra will be really involved here. Right? Let's see what that intersection point might be. But Shane, now, you mentioned to me something. Here we go. I've got these two graphs. Guys, they are going to intersect though. True? So this red graph, let me extend it for a reason here. It does that. The black graph looks good. Now suppose I ask a student to come up here and I'll do it myself. And suppose I graph on the same grid this x or y is equal to x. What would y is equal to x look like? That's what it should be, equal to x, right?
Yeah.
Is it a straight line?
Yeah.
Slope of 1 going through the origin? So it looks something like this. This represents y is equal to x. Yes or no?
Yes.
Now, does anyone see any relationship between that line and my red graph and my black graph? Do it again. I heard something. Oh, right here. Mr. Parks will find the intersection point for me, I think. Mr. Parks, you found the intersection point?
The calculator says, I actually plugged it in the wrong.
Go ahead and find that for us, just out of curiosity. Guys, in your other relationship, I heard something. Look at the black graph. Here's the black graph here. The red graph's down here. The red graph's here. The black graph is here. What relationship am I looking at here?
Symmetry.
What could you say in mathematics?
Symmetry.
Is there any symmetry going on?
Yeah.
Is there some reflection going on from that black to the red? And it looks like maybe this piece reflected across that diagonal line would give me this. Or vice versa, this red reflected across that line would give me this piece down here. Is that true? It always happens. If you graph a function with its inverse and draw this, y is equal to x, you have symmetry around that line. Y is equal to x. So I thought we'd throw that in. Mr. Park, I'm gonna move on, but just tell me when you think you have it. Whoa, it's a strange point?
It's one is straightforward and one is a strange one.
Okay, right here. What did you find for the coordinates?
It says like 5.302 and one.
5.302?
Yeah.
And what you find for the y coordinates?
5.302.
Oh, they're the same. Does it make sense they might be the same? No one said 5.302. By the way, Shane, is that point out? Okay, it's to the right of 3. And that was the restriction to begin with. X must be what, greater than or equal to 3. Mr. Park, thank you so much. I would have never guessed 5.302 is the intersection point on that. And guys, that's all one problem, find the inverse, we checked it, and in fact, I even drew a graph here for this one. Guys, any concerns here? Question? I'm gonna go into part 2. Now, bring all this together, hopefully together here. Yeah, I'm gonna do this. Given this function. Now, notice your textbook, you guys are doing your homework. The textbook, the author of the textbook, and the author of the textbook was here on campus not too long ago. And we asked a question for him. Let's see if I got this right. Okay. Looks like that. I want to find the inverse. Now here's the question we asked the author of the textbook. You guys who are doing your exercise. He places on the side of his exercises or in the directions, so you guys don't have to worry about it. He tells you it is 1-to-1. So you don't have to worry about it not being 1-to-1, like I did on this one. He tells you ahead of time, it's 1-to-1. In other words, you can find an answer. So on the side here, without me worrying too much, this function is this. Therefore, I know I'm going to do what I gotta do. I can find the answer. Find the inverse, interchange first the coordinates. No problem. Done. Secondly, solve for y. Only 2 steps. Guys, to solve for y, I'm going to do a quick cross multiplication and have this is equal to this. Now, I've got to be careful. I got to solve for y. I've got a couple of terms that contain the y. Let's get the terms together that contain the y. Move this over out of the way. We'll have xy subtract 2y is equal to a negative 4x subtract 3. Why did I get those terms together? For what purpose would I have to get those terms that contain the y?
Factor out of one.
Yeah, we'll factor out the y. I need to. I still got this. Make a quick division, no problem. all the algebra here. Divide that by x minus 2. If there's no mistake, I hope not, this is the inverse. That's the inverse of this function. Now, Shane, there was no restriction on this one. They didn't say x is greater or equal to 3 or whatever. It's just open. Yes?
Would you get the same result if you, instead of moving 2y, you move xy? So,
Oh, got you. You mean move this over here?
yeah,
You'll get the same response.
same.
After you cleaned up, you'll get the same response. Guys, right quickly, I'm just test one here. At random, I'm going to choose a point here. I'm going to let x be 0. If x is 0, and I replace x by 0 in the original function, I think I get negative 3 over 4. If this is the correct inverse, at least for that one point there, when I interchange, this should satisfy that. I hope it does. So I'm going to replace x here by negative 3/4. I see right now the 4's will cancel. This becomes a positive 3. 3 subtract 3, 0 on top. It's going to work. So this is correct here. It will interchange it. And you can test other points here. Now to make sure it's correct inverse, here goes. Since these are lengthy, I'm going to ask you to probably find this composite just in one direction. And keep in mind what you're after. You're after x. Supposed to get an x, if it checks. This means find the composite f of the inverse. Now I'm going to start my work. Guys, the inverse was, we think, this down here. I'm going to close this down over this, half of this. Keep in mind, we're going to clean this up and hopefully it comes out to be an x. All right, guys, f of that means, and we're running out of space here, go back to my original function up here, replace. It's going to look strange, I mean really strange. It's going to look like this. Over this, subtract 3, over, you're not going to make a mistake, this, over this, plus 4. Everyone agree? Did I replace it correctly? I hope so. Now, if I were to see where you are right now, and even me standing here, this is supposed to simplify merely into, where am I going now? That. That's the check for an inverse. If it doesn't, we've got a mistake somewhere. Guys, to clean this up, here we go. Out front, we'll call that negative 8x, subtract 6, over x minus 2. If you don't mind, I see a 3 on the end. I need a common denominator. Would you guys mind if I write that 3 on the end like this? Just so those two terms have the same denominator. Okay, the bottom part down here, a negative 4x subtract 3, plus, I got 4 there. Since I need a common denominator, I'm going to rewrite that 4 as this. Let me step back and look at it. Would you guys agree with that? Hopefully, it's messy. All this will work out for us. Here goes, guys, back on the top there. Got to be very careful. This is a negative 3x plus 6. Just that part. 6's will cancel. Looks like it's a negative 11x over that common denominator, and there's the top part done. Bottom part, this is 4x subtract 8. 4x is canceled. A negative 3 and negative 8, that's a negative 11 over that common denominator. Please tell me, is that going to be x? When I finish it up, will that be x? Without me going through all the detail, I know these are going to cancel eventually. Where the negative 11's cancel, and I'm left with what? X. So that right here, where was it? This is the inverse of this. Now, am I gonna graph this one? No. Why? You guys just had an exam. This is a rational function. This thing right here, if you were to graph this, like you did the one on the exam, this thing has a horizontal asymptote at where? Where's the horizontal asymptote if you were to graph the original function here? Where's the horizontal asymptote? You guys have already forgotten. 2. That's the horizontal. If this is the inverse, that horizontal should turn into the vertical for this. Is the vertical asymptote for the inverse 2? When I set that denominator equal to 0 and solve for the vertical, is that 2? So the horizontal from here turns into the vertical from here. Things are being interchanged. That's what an inverse does. Quite quickly, what's the x-intercept up here on the original function? X-intercept. These weekends are killing us. 3/2. The x-intercept is it 3/2?
Yep.
That x-intercept for the original should turn into the y-intercept. What's the y-intercept down here? Replace all those x's by 0, what do you get? 3/2. Is that true?
Yep.
So everything's being interchanged. That's what should happen for an inverse. And we checked it. Oh, did we ever check it? It's this. We got x. Whew. Now, before I leave it, can anyone tell me some way to express the domain of that original function? X cannot be, or you're -4. Can someone tell me what, and be careful, think about it, what is the range, and you might want to visualize what this graph looks like. What is the range, do you think, of this function?
Y cannot be 2.
He's telling me y cannot be 2. Did you visualize a graph? Would this graph, if you were to graph it completely, is it a rational function?
Yes.
Is this horizontal asymptote, you guys know the horizontal asymptote is what, up at 2? So is my graph, if I were to graph it approaching 2, so it looks like up to 2, so it might be. You say, Professor, I'm not good at visualizing. You're not? Here's another way to find it. We think y cannot be 2. Okay, if you can't find it by visualizing, why not? Where are we? I'll go here. Now, suppose I go to the inverse, not the original function, the inverse, and ask you down there, what is that inverse's range? Let's put domain first. What is its domain? X cannot be what?
2.
2. I heard the range up here on the original was what? Something cannot be equal to 2. Is that true? So if you cannot visualize what that graph looks like, why not jump down here on the inverse and find its domain, and should the domain of the inverse be the same as the range of the original? Everything being interchanged. Now guys, let me finish this up. That's domain. The range on this one, for the inverse, that should correspond with the what? Domain of the original. So it's what? Y cannot be equal to 4, -4. Wow. Wow, wow. Let me put on the side here, I'm gonna clean this up. Done. Conclusion. The domain of the inverse, if you're asked, should correspond with the range of the original. If you're asked for the range of the inverse, that should correspond with the domain of the original. That's true, guys? Woo, and we got the check out of the way. I'm done with inverses. You're not done. I'm done with the inverses. Guys, any concerns there? Look how fast I've covered the board there. So can we find the inverse? I hope so. We missed the domain, the range, with all this added detail here to work with. Okay? Now, I may have a little bit of room here to get a start here. Part 3, here we go. In chapter 4, all of a sudden, as we don't have enough to worry about, They go into another function. Another function, as if we don't have enough. How many more functions do we want? We've already done polynomial functions. We did rational functions. We've done quadratic functions. We did absolute value functions. Where is this? By the way, we are creating a new course here at SMC will be offered in the fall called Math 6. And Math 6 is really, I think they're going to name it functions. I think that's the name of the course. We'll start a new course here. Exponential. In exponential, I see the word exponent. So it has something to do with an exponent. Now, what I thought about driving in today, thinking about this, and we'll have an accident one of these days thinking about this. I was thinking about this to lead into it. I suppose, here we go. I'm going to do a table, like quickly. Place some points to look at, and I'm going to do this. Now hold on, I'll tell you what's going to happen. That's 2 cents. 4 cents. 3, 8 cents. And we'll go to 4 and make this 16 cents. I just created this driving in. Let's see if it works. In this table. Let's assume that those numbers in that table represent this. I'd like to have my students attend class. You know, when I first met you guys, I told you the importance of being here. And I checked attendance every day. If you're not here, I usually send you a note. Have you dropped a class? Something to that effect. So maybe my students are not showing up, and I'm nice. And I'll say, okay, every day you show up, I'll give you 2 cents. No, that's not much money. Day 1, you get your 2 cents, you smile. You come back day 2, you don't miss, I'll give you 4 cents. Here, I'm going to change this to 8 cents. And let's do 16 cents. Is that true, guys? I'm just coming up with some numbers, and I'm at the door to greet you with a smile, and I'll give you that money. On the other hand, let's call this T for time. And this is money here, just Y. Now, on the other hand, let me do this. T for time, put Y. Now, suppose it works like this. Okay, I get 2 cents here, 4 cents here, 6 cents here, 8 cents here. A little different. And I asked the class, would you prefer, and I'll go to each one of you and ask you which one would you prefer. Would you prefer I'll meet you at the door and give you this, which looks like it might be tempting, or this, which is also tempting, it's money. Let me step back and look at it. Who has an idea? It looks like the first one, it looks like those numbers are getting large, fast, aren't they? In fact, they're getting so large, this is amazing. That's what's coming up for exponential functions. Let me point out something here, this blue will work for me. Point out something here. Can anyone tell me, let's try this one first. Can anyone tell me a relationship, a formula, an equation that would relate day 1 you get 2 cents at the door. Day 2 you get 4 cents. Day 3 you get 6 cents. 4, 8 cents. Shane, tell me something in terms of T and Y, like a function that represents, or that table. Tell me.
Y equals 2t.
Beautiful. When time is 1, 2 times 1 is 2. When time is 2, in her formula, 2 times 2 is 4. When time is 3, the third day, you get 6 cents, 2 times 3. Now, can anyone tell me this one? Oh, look at hands going up. Yes?
T plus 2.
Tell me again.
Y equals T plus 2.
Now, I'm trying, hang on. Now, if I try day 1 says if you use this formula, it's 1 plus 2, that'd be 3 cents. I'm giving you 2 cents. Looking for answers. Maybe look a little strange there. Daniel, what you got?
T squared.
Tell me again.
T squared.
T squared, hang on. I did bring this in for a reason. Okay, Daniel says this. Daniel will test it. If I put day 1 in here, I get 1 squared, I should give you just 1 penny. I'm gonna give you 2. So it's not T squared. Oh, this is cute. This is cute. I see a hand going up, I know. Hang on just a second there. Yes, Billy?
Y equals 2 to the power of 2
Whoa, hang on. Y is equal to 2 raised to a power
of t.
of t. She gave me an exponent to work with. Billy, if that's true, if I put a 1 in there, 2 raised to the first, 2 cents. Put a 2 in there for t, 2 squared, 4. Put a 3 in there for t in her formula, to what, 2 cubed? 8. Put a 4 in there, I get 16. Looks like that formula she gave me works for the table. And then over here, Shane gave me this for this one. Guys, I would now, look at this, and Mr. Park, I need your help here. Can anyone tell me, if I accept this, at the end of, let's say 30 days. Maybe I'll wait until 30 days to pay you all up together. At the end of 30 days, if I were going to use this to give you money, what amount would I owe you or give you on that 30th day?
60 cents.
60 cents. Wouldn't I? On the 30th day. How much would I owe you, Mr. Park, get ready, if I use this system model on the 30th day? It looks like this. And I guarantee you, when you hear the answer, you're going to be here the 30th day. Mr. Park, tell me what is 2 raised to the 30th?
It's like, I don't even know, it's like 10737.
Is it over $1 million?
Yeah, it's over.
It's over. 2 raised to the 30th, you would be receiving on that 30th day with a big smile on your face and say, I love Professor Ramsey. He just gave me over $1 million. Because I chose this model, right? Ignacio says, oh, I'm unhappy that 30th day. Why? Because he gave us a choice and I chose this one. I get 60 cents. True? We're talking about one like this today, where, Billy, thank you so much, she gave me t as an exponent. These are called exponential functions that we're going to be dealing with. Now, I thought I'd point out this. By the way, guys, look how fast this thing took off. 2 raised to the 30th. Mr. Park, please tell me, it is over $1 million, isn't it?
Yeah, it's over like 100 million.
Thank you. 2 raised to the 30th, over $1 million. Here, 60. And by the way, guys, this is linear. This is exponential. So with that said, we do this, and we're going to get the start of this good work here. Your textbook gives a definition, based on what I've done here, of an exponential function as this. I'm just put it on the side here. They give it as f of x is equal to a raised to the x. And it makes some restrictions. The a must be that, cannot be 1. So a raised to the x, which looks much like what Billy gave me. A raised to the x, this is just a general form. The base, a, must be a positive number, but do not let a be 1. The x at the top being raised to what number? Oh, they say this. Let x be any real number. Now, I wonder why they leave out 1 for the base. Yeah, what is 1 raised to anything? 1. So trivial, they say, please don't do that trivial part. Leave out 1. So guys, if it looks like this, it's considered an exponential function. Now, I'd like to sketch a very simple one here, for a reason. I'm going to start with this. F of x is equal to 2 raised to the x. And I can use 2. Since I had tables here, I think I'll do a table right quickly for this, just to see what's going on here. You guys got x, 2 raised to the x. Let's try a few numbers. Maybe a few negative numbers. I'll throw those in. Let's throw in 0 and a few positives. And keep in mind, x is open. I may replace the x by anything I wish. With the selected numbers I have here, I did this for a reason, guys. This is 2 raised to a negative 2, which I think is 1/4. This is 2 raised to a negative 1, which I think is 1/2. 2 raised to the 0 definitely is 1. 2 raised to the 1 is 2. 2 squared in my table is 4. Now I'd like to go to a grid, plot those, connect them, and before I do it, can anyone tell me, because I think some of my students have seen this before, can anyone tell me what type of a shape do you think I'll get? You think I'll get a parabola? No.
Right side of a parabola.
Straight line? No. Polynomial? No. What do you think?
The right side of a parabola.
Right side of a parabola, okay. Give me another description. I have not applied my points yet. Okay, I see a student showing me there. Let's see what this looks like. Guys, based on the few points I have in that table, it should be enough. Let's see what this might look like. Okay, on the grid, I start out with -2, so let's put that over here. 0, 1, 2, should be enough. Now when I start applying points, I have -2, I go up to 4, I guess. There we go. Just get ready for it. Now let's plot points. Just plot points, connect them. Let's see if this is a straight line or not. Guys, my first one says -2 up 1/4. -2 up 1/4 is barely above the x-axis, somewhere right in there. -1 is up 1/2, a little higher. 1/2 right there. 0 finally gets up to 1. Plotting points. 1 goes up to 2. 2 goes up to 4. I think I plotted those correctly. Connect, and I think I'm gonna get a curve like I saw students showing me here. Guys, when I start connecting to get the full graph, please tell me, do you think there's a horizontal asymptote here involved or not?
Yes.
When I start connecting the rate points, where's that horizontal asymptote located? The x-axis. So my graph's getting awfully close to the x-axis. It's coming up like that. Picks this up and go right through here and on like that. Would you guys agree that's a rough sketch there of what the function may look like? And that's a function f of x, in this case 2 raised to the x. Whew. Now we list the domain and the range on this function. The domain on this function, if you look at the graph, the domain is, of course, negative infinity through positive infinity, all real numbers. Range on this function, the up and down, you would describe the range as what on the rate graph? 0 through infinity. Cannot include 0. We'll never get there. Horizontal asymptote, I'll put it right here. There is 1. You guys named it for me. Y is equal to 0, which is the x-axis. Is a horizontal asymptote. No crossover point. And there's my graph. By the way, please tell me, does that graph, as I go further out this way, does it really shoot off really steeper and steeper and steeper real fast? Like this, where was it? This table was doing it. Real fast. That's moving really fast, not like a parabola. Much faster. So that's the first case of an exponential function. Now, with that said, let me see how much time I got here before we take a break. Beautiful. I'm gonna throw this in now. Find, here we go. That function's inverse. I have the function sketched. Now let's find its inverse. I'm gonna use the same 2 steps I used over here to connect lessons here. Step 1, if I want to find the inverse, step 1, first, is my function 1-to-1? Is my rate graph representing a 1-to-1 function? If I use a horizontal line test, so it has an inverse. What is that inverse? The 2 steps. Here we go, guys. First step, interchange. Oh, beautiful. I get partial credit for showing that. Only 2 steps. Step 2, and I'll remind you, to find that inverse, step 2 says now, please solve for y. Now I have some clever students in this class. Does anyone think they know what to do to get the y completely by itself? Because I did one over here, right here. Here I got the y by itself. I got the y by itself on another one earlier. And step 2 says, please get the y by itself. Does anyone have an idea of how to get the y by itself? Alex.
This is right, but.
Beautiful. Tell me again.
1 over y.
If I were a student, Alex, I'm the same as you, I said, Professor, come on now. I'm at Stanford now, and they're asking me to solve for y. I'm desperate. Trying to get that y by itself. So divide both sides by 2. I'll tell you ahead of time, no. Alex says divide by maybe y. Divide both sides by y. No. That's why I love teaching. That looks so simple to get y by itself, and it's not. It's going to take me into another category altogether, which I need to go. Shane, what do you think?
Is it the root of y?
Beautiful. I've heard root. I heard take divide by y, divide by 2, and I'll take a root, and I'll tell you just to save us a little time. No. Alexandra.
Is it log?
She says, Professor. She just mentioned something I haven't mentioned yet, which I'm going to. She says, Professor, since you can't do it the way we're trying here, she says, Professor, I remember something called a logarithm, or abbreviated LOG. A logarithm. LOG. Some of my students say, Professor, I've never heard that word in my life. And the abbreviation is LOG, log. Found the log. Alexandra, I don't put you on the spot. Tell the class then what is y equal to. Well, you solve up here. What is y equal to? And then I'll bring you in and talk about this. What's it equal to? What do you think? Tell me again. Not 1.
Log base 2x.
Whoa. Ignacio, tell me again. You're going to use LOG,
Yes.
logarithm?
Base 2.
Oh, base 2
Yeah.
of x. Ignacio, so you're telling me this is the inverse? Ooh, the class got quiet. Professor, jeez. You better introduce something. Alexandra introduced this for us. She says something about a logarithm. I had not discussed, I hadn't used the word logarithm before, had I? No, not at all. That means if I want to continue, I had to go on the side here before we take a break and discuss a little bit about logarithm and how it's connected with an exponential. By the way, guys, you see one exponential function at this point. So guys, on the side here we go. I don't want to mess my board up here. Let's go up here. Let's call this part B. This. A logarithmic function. Something I have not discussed. Alexandra brought the word in. She says, Professor, I see it. And I think you have the handout. I think I gave you guys this handout last time. Definition. Y is equal to log, Ignacio, you gave me something like this. Log base A of x means, this is the definition, A raised to the y is equal to x. Oh my goodness. That's the definition of a logarithm, a log function. So if I see this, you in your mind are saying, wait, Professor, it means this. The word log's gone. So if I see this, by definition, it means this. Therefore, before I jump back to my problem there, anyone tell me the log base 2 of 8 is equal to what?
3.
I heard 3. Now, can you tell me, based on this definition staring at me right above there, can you tell me now what that looks like if it's a true statement? What does that look like in this form? What is log of 8, base 2, our student says equal to 3, what does that look like in the form A raised to the y is equal to x? What does that look like? 2 raised to the what? Third is equal to 8. That's the way a log works. Now, if that's true, let's go back. Alexandra, if we accept this, please tell the class what this would look like by definition, right here. What does this look like here?
The first one.
Yeah, this one down here?
It looks like number 1.
Oh, it looks like number 1. 2 raised to the y, like this,
Yes.
is equal to x. Is that true, guys? The way it looks? Now, let me slow down a little bit. I have in the red graphed, thank you, Alexander. Have I graphed this one? I've already graphed this one. That's the red graph right there. We did it with a table. Now I'd like to graph this one, which is really graphing this. Is that true? They mean the same thing. So guys, with the help of a table, and boy, is this going to take me to a good point here. Let me erase this table, or information, leave that table, and now ask a student to help me create a table for this. Oh boy, it's 2 raised to the y is equal to x. This table, it might be better to put the y here and the x here. What do you guys think? Is that true? Interchange them? Oh, by the way, does an inverse supposed to interchange them? So I've interchanged my coordinates. It was x here, then 2 raised to the x, now it's interchanged. And now for the y here, guys, should I try these numbers again? I'll put those in there. The x should be equal to 2 raised to the y. This is 2 raised to the negative 2. Is that 1/4? Is that true? This is 2 raised to a negative 1. Looks like it's 1/2. 2 raised to the 0. Looks like it's 1. I know we're repeating some numbers here. This is 2. And 2 squared is what? 4. Is that true? Now I'd like to plot those points on the same grid and graph it. They say, Professor, you're going to get the same graph. No, I'm not. Am I going to get the same graph? No. The x in this case is what? I've got to be careful here. Is the x in this case 1/4? And the y is what? Negative 2. But tables turn around. This one is 1/2 negative 1. This one is 1, 0. Do not let me make a mistake here. This is 2, 1. And this is 4, 2. Now let me plot those in black. On the same grid. Now they're labeled. That's what's going on here. The red graph represents this. 2 raised to the x. My next graph coming up in the black, let me plot the points. I got 1/4 down 2. Oh my goodness. 1/4 down 2. Okay. And I'm going to start out with maybe a point in here somewhere. Now 1/4 down 2. Is it true? Next is 1/2 down 1. A little further out, down 1. 1, 0. Let me squeeze that 1 over a little bit. 1, 0 is there. 2 up 1 is in here somewhere. Out 4 up 2, since I have it, why not? Out 4 up 2 in here somewhere. Right? Connect those points, and we'll go again. If I connect those black points, I have, what, 5 of them? 1, 2, 3, 4, 5. Might I get a graph that looks something like this? Yes or no? Now what's that black graph representing? It's representing, yes, it's representing this 2 raised to the y is equal to x. It's representing log base 2 x. So there's the exponential. Next to it, its inverse, which is a log, together. And maybe 3 minutes. Can anyone tell me in class what else should I add to this grid to make it more understandable? Shane, tell me.
Line of x equals.
Absolutely, absolutely. Throw in that line y is equal to x. I'll go ahead and do it right here since I'm a little rushed here. She says, Professor, go ahead and do this. Which is y is equal to x. By the way, is there some symmetry between those two? The red graph and the black graph, if that y is equal to x, and there should be some symmetry. Now before I close down, that's a good start. The black graph. The black graph is, the red one was the original function, this one, exponential function. Its domain is open. What's the range on the red graph? 0 through infinity. Like that. Now let's go to the black graph, which is supposed to be its inverse. The domain on the black graph is that 0 through infinity.
Yeah.
The x's. The range on the black graph, the up and down, is what? Negative infinity through infinity. Please tell me, do the domain and the range interchange? As we pointed out somewhere here. Do they interchange like they should? So there you have the exponential function, you have inverse, which is the log, graphed together. Wow. Trying to get this chapter 4 done. Guys, any concerns here? Anything at all? Make sense? Woo. Wait, hold on. I got just a few seconds. I'm not going to do anything heavy. Just a few seconds before we take that break. Got all this done. Oh, why not? Can anyone tell me, and it's going to lead me into after we get back from the break. Suppose you have this. It's got log base 2 x plus 4. I'm not going to graph it. And I ask you, what is that function's domain? Can anyone tell me, where am I going after the break? On the domain on log base 2 of x plus 4. Oh, by the way, guys, the way this thing looks, would that be a horizontal shift of the log graph forward to the left?
Yep.
I'm not gonna graph it, but that's what it means, forward to the left. So if I graph, it should graph it, just visualize it, this is the, where is it? Is it this graph right here?
No,
Is it the red graph or this one?
no.
That's the black graph, and black graphs mean what? Horizontally shifted forward to the left. Visualize. So this black graph is going over here. Here's your vertical asymptote. It's over here now. Is that true?
Mm-hmm.
Now tell me the domain.
Negative 14.
Beautiful. Oh, by the way, do you think I can include -4?
No.
No.
Beautiful. Now, before I close down, how can someone tell me a faster way maybe to find that domain that Naso gave me if I did not have the graph to look at? He's asking, find the domain, there's no sketch there. Shane?
The range of the inverse function.
Oh, hang on, hold on. The range of this function.
Well, the inverse.
Oh, okay, of the other function. Yeah, I have to graph something here. Something a little bit faster. Anyone see a way to find that answer quickly? The domain of this function must be this, and I did not have this visual sketch to refer to.
You said it equal to 0.
Close. Then what would you do? Right quickly, algebraically, no graph, and find the domain. And then we'll take a break. Oh, it is. It's going to make it so easy. Yes.
X plus 4 more than 0?
Beautiful. X plus 4 must be greater than 0. Solve for x. Please tell me, are we saying the same thing? And no sketch. Now, can you tell me why, before we take a break, why do this? Why make that inside part greater than 0? There must be a rationale. Why? Why set that part greater than 0? Not greater than or equal to, just greater than. Shane?
The domain of the base function.
Yeah, look, this is my base. Here's my parent function. What's the parent function say? The domain must be what? 0 through infinity? So this must be greater than 0. This x plus 4 must be representing something greater than 0. Written like that, we got it. Wow. Guys, take your well-deserved break. We got 10 minutes. If you did not pick up your exam, I have those.